All right, good evening, everyone. We're SignIt. Our backend team was Rigre, JB, and Francis, and our front-end team was Jeshna and myself, Rahul. ASL is the third most studied language in the USA, according to Forbes magazine. 1 million people use it as their primary language. Additionally, with nearly 600,000 hearing-impaired individuals in the US, as well as calls for a more inclusive society, ASL has become more popular for communication in areas like business. However, knowledge and understanding is not as widespread. Thus, the question this project sought to answer is, how can individuals like you and I communicate with this diverse community? Our answer is SignIt, an app that works to build bridges between ASL and society. Rigre will now give an overview of the app's features.
All right, thank you. So our main two features are translation and education. Using our translate page, users are able to take a picture of any ASL sign letter that they want, get an instant translation into English pop up at the top of the screen. This is done using a custom machine learning model that we have trained over the course of the semester. And as you can see here, I am signing the classic phrase, hello world, and the model is guessing it perfectly. Here comes the L, and then finally the D. We also have an education page where users are able to click on any letter that they want and learn how to sign it. This feature can be used in tandem with our translation page. So for example, users can learn how to sign a letter and then check if they are signing it properly by seeing if the model identifies it properly. If it doesn't, that means they are probably putting a finger in the wrong place or doing it at the wrong angle or something. So now Francis will go a little deeper into how all of this works under the hood.
All right, thank you, Rigre. So for our tech stack, we decided to use Flutter as our main framework for the front end, and that uses Dart as its main programming language. We chose Flutter because it's cross-platform, meaning we can create one code base and extend that to both an iOS app and an Android app. And then for the back end, we decided to use AWS's cloud computing services to both train the model and run inferences and communicate with a backend with the app as the edge device. We chose AWS because it's more cost efficient to train a model with AWS than compared to something called like Google API Vision or other AutoML solutions out there. And it's also horizontally scalable. Over here, we have a diagram of how everything is happening behind the scenes. So we have the user's phone, which captures an image. We expect it to be an ASL hand sign. And then that image is processed and sent to API Gateway, which is an AWS service for how edge devices like a phone can talk with other AWS provided services like Amazon Recognition. Amazon Recognition is the actual AI part of the app. Here we built a custom AI model and trained it over our own data set of ASL hand signs. And what it will do is we'll analyze the image from API Gateway and translate that into an actual text translation and send that translation back through API Gateway and then display it to the user's phone. Now over to JB.
We're not the only ones in the market, but our competitive edge comes from key advantages we are able to provide over other services. Most other apps are only text to sign, meaning they can only translate one way. Other apps offer real-time translation, but at the cost of having to have real people online 24/7. We believe we are the only ones that can offer a true instant translation experience. Now we'll talk about some of the challenges we've had while developing.
So one of the biggest challenges that we had was actually training the model to be accurate enough. We ended up going through over 10 different versions of it, each time tweaking the data sets a little bit so that, for example, the model would be able to distinguish between letters, signs that look very similar, and also so that it would be able to identify signs in a variety of conditions. So for example, different lightings with different backgrounds, or even in different places on the screen. And this took a really long time because we had to go through thousands of pictures. But in the end, we ended up achieving an average confidence level of 85%, which is pretty good.
An additional challenge that we experienced was setting up the API endpoints for the model to be able to talk with an edge device. And this was something we were able to overcome by learning how to use API Gateway.
And lastly, we faced the challenge of creating an intuitive user interface. We took inspiration from popular social media apps and applied it in our own way. Wireframed it in Figma and then created it in Flutter. So what's next for SignIt is what we want to move away from static image input to video input, as ASL as a language involves a lot of movement and gestures that translate into whole words, and letters like J and Z require movement. Additionally, we would want to expand the education page to be more similar to Duolingo, where our users can learn each letter and phrases and scale up in their learning.
We also want to introduce account functionality. We want you to be able to save your past translations and your learning progress. We'll be able to use the extra data to train better versions of the model periodically as well. We really think that with more time, SignIt can help improve the quality of life for a marginalized community. And we hope that you feel the same way. We're now open to questions.
Very impressive. And how long did you guys take to work on this? Did I hear a couple of months is how long you guys had for this?
Yeah, it was the semester, pretty much like 2 months, I believe.
Yeah.
Yeah, over the course of 10 weeks.
Yeah, 10 weeks.
10 weeks. Very, very impressive. I noticed that in the demo, which by the way was very impressive, you had to give your signs with a blank background. Is it difficult to do it with someone in front of you, or
It is.
or did you have?
We did test it with our face in front of it and everything, and it does work. With that, yeah.
I think there's some real practical applications to this beyond this. So I think you could scratch the surface on something that could be very beneficial to the community and could also make a lot of money.
Very thoughtful idea. So have you trained the algorithm enough to capture all of the different signs?
So as we mentioned before, the letters J and Z are with movement, and our current model only uses letters. Only uses pictures. So it is those two letters are not currently functional, because for that we would need video, which was a little bit more expensive. But that is definitely stretch goals for the future.
Excellent, nice work.
Does someone know sign language on the team?
No, I don't think so. I don't think any of us know any sign language.
You know a little bit now, I think, right?
No, we
Yeah.
didn't learning it for sure. We
Great.
tested it.
I love the idea too, like you mentioned at the end, of having possibly making like a Duolingo version of this. I have an aunt and an uncle who use ASL, and my whole life I haven't been able to speak to them. And so, right, having the idea of having something like this where I would be able to teach myself and keep learning, it just sounds so amazing to have in my pocket. So awesome job, and great like creativity to keep thinking forward.
Thank you.
Awesome, you guys.